Hey Carter, we're on the back side of chapter 4 review. We've just got a little bit left.
What is this?
And that's all. What?
Did I get one of these?
Yeah, you have it from yesterday.
Oh, is this in a
I
binder?
definitely filled
Probably.
this out yesterday.
Yeah.
I definitely did.
Yeah, I gave you. So you must have already had a copy, and I just gave you a second one.
So stupid.
You know, if you had a folder that actually organized your papers
Billy,
other than your
yeah, Billy,
computer
get
one
folder.
like that
Get
one.
one of these. No.
He already has one. It's just not in it. Whatever. All right, we're on 10.
This one doesn't have a hole.
Okay, let's do 10 together, and then you can do 11 on your own. Here we go. Points of inflection. They don't even ask for increasing, decreasing. They're only asking for points of inflection. So we have to focus on the what? Why is he not writing for me? They're only asking on 10 and 11 for points of inflection. So we only need to worry about the what?
Wouldn't it be
Nope.
like 0, -1?
We only need to worry about the second derivative. Yeah? This pen is not working.
Oh, wait, no.
What happened to it?
Y, so it'd be -1, 0.
Oh, that's why, because he's frozen. Hold on. Un momento, por favor.
On number 10. Because you just move him
I
to the
don't
left
know.
one, right? So that means his boy would just be to the left.
Yeah, but we gotta find the derivative.
Oh, right.
We gotta find the second derivative, right? Yeah, now he's writing. Okay. Second derivative of this guy. Do you want to do the chain rule? Yeah, I like it. Okay, chain rule. 3 comes down in front. Leave the middle. Squared. Derivative of the inside is just 1, so that comes out nice, right? I'm gonna get rid of that 1. I'm just gonna leave it off, right? And that's first derivative, right? We want to do second derivative. So this is f prime. We want to do f double prime. F double prime, 6. X plus 1 to the first power times the 1, right? But whatever. So now I can distribute the 6 through, right? Like before you couldn't distribute that 3 through because it's squared, right? So this is 6x plus 6, right? Equals 0. Subtract the 6. 6x equals -6. X is -1. So I only have one possible point of inflection. And I need to do a table, and I don't know where to do that at. Let's do them right here. Table. How many columns on my table? 2. Going from -infinity to -1. Going from -1 to infinity. What points you want? -2 and 0. Sounds good. And we are plugging into the... Which one? The second derivative. We're plugging into the second derivative. We're looking for concave up, concave down. Okay. All right, second derivative is it 6x plus 6? Okay, if I plug in -2, you get negative. If I plug in 0, I get positive, which means this guy is concave down. And this guy is concave up. All right. Concave down, -infinity to -1, concave up, -1 to infinity. Do I have a POI? At -1 comma, you plug him in, 0. Oh, where'd you plug -1 into to get the 0? The original, right? Yep. Okay. All right. You get a head start on 11. Go. He should be real easy. He should be real easy. I'll give you like a 15-second head start, and then I'll go.
The frick? Why?
What?
Why did you like that?
What do you mean? I don't know what it is you are talking about. Don't cheat. Don't cheat.
I was looking at that one because I was trying
Uh-huh.
to figure out which one's concave up and which one's concave down. Positive though.
Of course, positives up.
I'm just thinking out loud. Now my brain hurts. Why do you...
Do we have 6th period before lunch today?
Yes.
Okay. All right.
Not very excited.
Uh-huh. And then negative 54. Is that what you got? Yeah. Get that? Yeah? Yeah? Beautiful. I think Daniel's ahead of us. Yeah? Okay. All right. 12. Yeah, we got all the things on number 12. Woo! So number 12, just so you know, is a combination of this guy and this guy, right? So on number 12, we have to do the first and second derivative, yeah? Okay, I'm going to do my derivatives, I think, potentially over here. All right, f prime. Okay, no. We don't have to do that. This is not a product rule.
I was just saying that.
Whoop.
Yeah,
Okay, f prime. Go. What's the first derivative?
Negative 3x squared plus 12x minus 9.
Awesome. Okay, double prime.
Correct. Negative 6x.
Nice. Okay. Oy vey. All right, we got to set this guy equal to 0 up top here. Okay, what would you like to do?
What?
You could. I want to divide by negative 3 and throw it in the trash. Can we do that? Then it would be simple, right? You did this way harder than you needed to? Yeah. Minus 4x plus 3 equals 0. Multiply to get 3, add to get 4.
Negative 3, negative 1.
Yep. So x equals 3 and x equals 1. So those are potentially what? What? Those are critical numbers, but they are potentially what?
Inflection.
No.
No, wait, actually, what are the first ones?
What do the first derivative guys tell you?
Let me think. The first derivative tells you...
Yeah. Where it's increasing and decreasing, so maxes and mins. Those are my potential maxes and mins. I don't know which one they are, but we'll find out. Okay? All right, set this guy equal to 0. I'm going to add the 6x over. So 12 equals 6x and x equals 2. And that guy is a potential POI. All right. So we need a table that has 4. I'm going to make my table right here. 4 wide. Okay, so we need the intervals. I need my test point. I need my f prime. I need my f double prime. And I need my conclusion. All right. Beautiful. All right, we're going negative infinity to what? 1. We're going 1, 2. 2. Ugh. We're going 2, 2. 3. Ugh. We're going 3, 2. Infinity. All right. Okay. So what should we use? 0, of course. 1.5, 2.5, and 4. Sure.
10.
All right. Okay. All right. Now.
No one likes my idea. So stupid. It'd be so cool if we did 10.
All right. Here's the issue that we have. The first derivative. I am tempted to use this guy because he's completely broken down. But the problem is, I divided off a negative 3. And if I use this guy, he will end up being the opposite of what we said he was, right? True?
Oh,
because we took a negative out, right? Okay? So we might have to use the original guy. Or we could use this guy. We just flip the signs, right? Let's just use the original guy. So my original f prime is Negative 3x squared plus 12x minus 9. Okay. We gotta plug all the junk in into the calculator. All right, 0 will be what? Minus negative 9. Okay, 1.5. All right, negative 3 times 1.5 squared plus 12 times 1.5 minus 9. I get 2.25, so positive. Whoa. Okay. If I plug in 2.5, this is 2.25. Okay, if I plug in 2.5, I get also 2.25. So positive again. That's handy. If I plug in 4,
What's that one place we went to with the bowls that you took up and they grow that Angus bill?
if I plug in 4, I get negative 9, and that is negative.
We go there for lunch.
Okay. Double prime is negative 6x plus 12.
Did I not tell you how sick it is?
Okay.
You didn't believe
All right. You can do this. Negative 6x plus 12. If I plug in 0, negative 6x plus 12, you get plus, if I plug in 1.5, what's negative 6 times 1.5?
Very good.
Negative 9 plus 12, positive. If I plug in 2.5, negative 6 times 2.5. What's 6 times 2.5? 15. So negative 15 plus 12, negative. If I plug in 4, negative 6 times 4 plus 12, that's going to be negative 12 or something like that. I don't know. Okay, good? All right, here we go. We have, right, I'll put my conclusion down here. Okay, this guy is what? What does this tell me? Decreasing, and he is concave up. Okay, this guy is increasing and concave up. This guy is increasing and
Cut down.
concave down. And this guy is decreasing and
Cut down.
concave down. Okay, so, all right, right here. What's he doing?
Min.
He's decreasing and then he's increasing, so he's a min at whatever 1 comma something. We'll find what that is here in a second. Okay, here he is doing what? He's a POI because he's switching concavity, right? Okay, so POI at 2 comma something. We'll figure that out here in a second. Okay, he right here is a max because he's increasing and then he's decreasing. So max at, is it 3? 3 comma something. And that's it, right? Okay, so let's fill in our stuff over here. We have increasing. Where's he increasing? Ugh. Oh, he's increasing here and here. Can I get away with just saying 1 comma 3? Yeah, from 1 to 3 he's increasing because it's like over that whole thing, right? Decreasing. He's decreasing negative infinity to 1, union, 3 infinity. Yeah, are we happy with that? Yeah? Okay, max, we have him at 3 comma something. Let's go ahead and plug him in. What'd you get? Negative 8, 3 negative 8. Cool. Min is at 1 comma something. That would be negative 1 plus 6 minus 9 plus 1. So negative 10 plus 7 is 3. Did you get 3? Awesome. That's my min. Whoop. You got negative 3? True. Yes. I can't math. Okay.
Stay in the mailbox.
Concave up.
Mine doesn't have a thing anymore.
Negative infinity to 2. He's concave up here and here. So we'll just go the whole way. Concave down. 2 to infinity.
Stay to the post.
And he has a POI at 2 comma something. If we plug it in, you get what? Did you get a number?
I did it for the
Negative 8 plus 24 minus 18 plus 1. So 25 and negative 26. So negative 1. You didn't get that or you did get that? Cool. Okay, there's our POI. Beautiful. What? The max is lower than the min? No. No. So he is a negative well, okay, let's just do it. Let's just plot those points. 3, oh, yeah, we have to sketch them. 3, -8. 3, -8 is down here. And that's a max. Did you plug it in right? -27 plus 54 minus 27 plus 1. He's at 1. That's the problem. Fix it. Fix it. Fix it. You two. You other two boys. The max is at 3, 1. Not 3, -8. Okay. But you can have a max potentially be lower than a min. I guess not in this case, though. He would have to be like an x to the 5th power function. Whatever.
Yeah.
Okay, don't listen to me. All right. 1, -3 is there, that point right there. And he has a POI at 2, -1. Okay. Oh, shoot, I did it in the wrong spot. You're right. You're right. -3 right there. So those 3 spots. What does he look like? -x cubed, going downhill.
It goes, ooh.
Like, woo, with those sound effects and everything, too, right? Okay, was this guy supposed to be a max? 3, 1 was a max? Yep. My min is right here? Yep. This guy's a POI? Yep. Looks great. Looks great. That's my sketch. Alrighty there. Alright, are we ready? Last 2?
Yeah.
Okay, here we go. 4 feet of wire is to be used to form a square and a circle. 4 feet of wire to do this square and this circle. How much of the wire should be used for the square and how much... Oh, and for the encircle to enclose the maximum total area. All right, so 2 things that we have going on here is perimeter and area, yeah? Okay, so if I'm talking area, if we make this an x by x, we have an area of x squared, right? If it's x by x, then our perimeter is 4x. Got it. The radius, I don't want to call it x, we're going to call it r because we don't necessarily know that it's the same like length as that. So we have 2 different variables. You could have called it y or whatever for the radius, but we'll call it r. Area is pi r squared, circumference or distance around is 2 pi r. So if we're talking total perimeter we know. Yeah. If we're talking perimeter, let's go perimeter. PERIM. Perimeter is what'd you say? 4x plus 2 pi r, yeah? And did you find it? Is it sitting there?
Oh, right here. I was looking at your shirts.
Oh yeah.
Oh, that's cute.
Yeah. Secondary equation area equals, I don't know, like x squared plus pi r squared. And perimeter is how much? 4 feet. Do they want this in terms of feet or inches, do you think? Hold on just a second. That paper, some of it is, okay, let me show you. Okay, some of this is, I don't know, like this one is like water resistant or whatever. I don't know
Okay.
that it matters,
No.
but some of these are water resistant. Some of it is just like paper, and so you can decide.
No.
Like this one, this bottom one, I think, is just more so paper. So, yeah. And then just be careful what, like, I always have to peel it to see which side is the sticky part because I can never remember. So, take as much of that as you want. There you go.
Thank
Do you need more than that?
No.
Otherwise, I can go searching for some.
Nope, that's
Okay,
perfect. Thank
okay,
you.
all right. Whew. Do they want it in feet or inches? Shall we put it in inches?
Yeah.
Because I'm going to guess that, like, those are going to be, like, smaller, and we're going to end up with really small decimals if we don't put it in inches. So let's go 48 inches. Okay, so perimeter's 48 if we add those all together. Ooh, gross. What shall we do?
Divide by chance.
Shall we solve for x? I mean, it doesn't really matter. They're both going to be equally ugly, I think. Yeah, let's solve for x. Sure, let's do that. Okay, solving for this x here. I'm going to bump this guy to the other side. So 48 minus 2 pi r is equal to 4x, yeah? And then divide by 4. Boop. So x is, if I put it in here, oh gosh. x is going to be 12 minus 1/2 pi r. Can I do it like that? That's what he is. That's what x is. X equals, okay, 12 minus 1/2 pi r, and I want to square that, plus pi r squared. Ooh, gross. Now what? What? Do you wanna foil him before we do the derivative? Otherwise, we can do the chain rule. It might be easier to foil him first. 12 minus 1/2 pi r, right? Because he's squared, so we have to foil. 12 minus 1/2 pi r. Okay, 12 times 12 is 144. 12 times negative 1/2 pi r is negative 6 pi r. But then I have another negative 6 pi r. Plus 1/2 times 1/2 is 1/4 pi squared r squared. Yeah, that's what he is. Ooh, that's gross. So he is 144 minus 12 pi r plus 1/4 pi squared r squared. Are we doing okay so far? And then maybe I just put over here. So that's this part plus pi r squared again. Right? So this was the part that I just foiled, and then I have that extra plus pi r squared on the end there. Okay, now what? Now I have to take the derivative. Okay, deriv. Okay, this one's gonna be maybe not so bad. What variable am I doing? R, right? Pi, keep in mind, pi is a number. Pi is not a variable. So looking here, I don't have to use the product rule, true? Because pi is not a variable, pi is a number, yeah? Okay, so what's derivative of 144? Gone. Derivative of negative 12 pi r. Negative 12 pi, right? R just goes away. Plus this guy, I'm going to take the 2 and I'm going to move him down in front, right? So 2 times 1/4 is 1/2, you're right. Pi squared r plus, this is a power rule again, so bring the 2 down in front, 2 pi r, right? Oh, good golly gosh. I set that equal to 0. Okay, this is not a quadratic, by the way. This is r and this is r. I kind of wonder if maybe we should just figure out what decimal this is and figure out what decimal this is. Yeah, solve for r. So this is, okay. I don't know. Negative 12 pi. This is negative 37.70. Well, let's say 37.7. Plus pi over, pi squared. Pi squared divided by 2. This is 4.93 r is what that is. And then plus 2 pi would be 6.28 r. Yeah? Equals 0. This is 11.22. Yeah? So I'm going to bump the 37 to the other side. So Daniel said this is 11.22 when you add these two guys together. R equals 37.7. And if you divide by 11.22, 3.36. And what are we in? Inches. It's a good thing we didn't do feet because we would get like 0.0 whatever. Actually not. We would get 0.25. Something like that. Okay. That's what the radius is of the circle. Now we got to find the dimensions. Okay, so how much of the wire should be used for the square? So they don't want dimensions. They want how much of the wire should be used for the square. Gross. So we're talking circumference, right? We know the radius has to be, where is it? 3.36 inches. So if the radius is 3.36 inches, then how much wire am I using? What am I plugging into? I want the 2 pi r. I want to know the circumference. So 2 times pi times that 3.36. How much of the wire will be used for that? 21.1 inches. Okay. Now, how much of the wire will be used for the square? We don't even know what x is at this point. But do we need to find x? I don't know that we need to find x. We could just subtract 21.1 from 48, right? 48 inches total. So like, I don't know, 26.9 inches. And then we don't even need to know what x is. I guess we could find what x is. Take the square root of 26.9, right? No. Take 26.9 and divide by 4. And that's what would give us. So like each x is going to be like 6 point something, right? Whatever. Okay. Ooh. So that one was kind of tricky in the fact that they asked us how much wire, not what the dimensions are, right? So we couldn't just stop with r equals 3.36. We had to actually figure out how much that would be as a circumference. Okay. Weird. All right, 14. A rancher has 200 feet of fence in which to enclose 2 adjacent rectangular corrals. Use calculus to determine analytically the dimensions that should be used to enclose the max area. So I'm trying to maximize the area. Okay, they have this laid out here, and I don't know, I'll do an aerial view of it. Okay, but they have this thing going on, right? And one of these right here is x, and one of these right here is x, and one of these right here is y, right? Okay, and 200 feet of fence is being used, which is the perimeter, but we've got like the little guy in the middle right here. So if I'm talking perimeter, or like the amount of fencing, that would be how much? 4x's plus 3y's, right? Okay, and that I want to be equal to, I'll put that up here in my primary equation, 4x plus 3y, I want that to be equal to 200, right? Okay, how do I find the area of that thing? 2x times y, right? It's like base times height. The base is here, the height is here. So 2x times y. Does it matter that there's that middle guy in there? No. It's not going to really affect, I mean, it might technically a little bit, but whatever. We're not going to take that into consideration. We're not taking into consideration that the fence posts have any like width to them. Because technically if you're going across the top, like they still could touch that area on the bottom. Whatever. I don't know. Whatever. We're getting too picky. All right. Now what? Which one? The top one for what? You want to do x? I want to do x. Because if we solve for x, we're dividing everything by 4. And dividing by 4 has an actual exact decimal place, right? But if we were solving for y, everything would be in terms of thirds. And then I wouldn't be able to use like 0.33 because that's not an exact decimal place. Does that make sense? Versus I could use like 0.25 or whatever, and it would. So I have the option. If I solve for x, I have the option of using decimals if I want to at some point. Was that clear as mud? All right, move the 3y over. That's negative 3y plus 200, however you want to write that. And I'm going to divide by 4. So x equals negative 3/4 y plus, and 200 divides by 4 nicely, where 200 does not divide by 3 nicely. 50. Okay. So now he goes right there. So 2 times negative 3/4 y plus 50 times another y. All right, should we distribute our 2 through here? Yeah, we might as well. What's 2 times negative 3/4? Negative 6/4 or negative 1.5. Now we can switch to decimals if we want to, I guess. Plus 100. But then I have to take times y over here on the back half, right? So negative 1.5 y squared plus 100y equals 0. We guess the derivative. Oh, wait, no. We haven't taken the derivative yet. That's just our equation. Blah. Come on. Deriv. Yep, if I drop the 2 down, that's negative 3y plus 100 equals 0. Okay, I'm going to bump the 3y to the other side, so 100 equals 3y. And y equals, now we're going to have decimals that aren't going to make sense, 33.3, we'll say. or 100/3. Whatever. 33.3 is my dimension for Y, so that's like the width of my fencing going on here. Okay? By the way, we know this. If we had 200 feet of fence and this was a perfect square, and this was like not had this guy in the middle, right? We would want to make it a square, true? But the fact that this guy is here makes it so these dimensions will not necessarily be the same, true? Like the X and the Y's won't be the same. Yeah, so now we got to solve for X, and we have an equation for X right here. X is this guy. So I have X equals negative 3/4 times, I'm going to switch to 100/3, actually. 33.3 is 100/3. That's what Y was, right? Because, look at this. Boom, what's 100 divided by 4? 25. So negative 25 plus 50. X is 25. Now, if we would have used 33.3, we would have gotten like 25.1 or 24.9 or something like that. We wouldn't have got the exact answer because we rounded the thirds. But whatever. So our X dimension is 25, but our Y dimension is 33.3. And what were they asking? To determine analytically the dimensions. So X and Y. Yep. And that's in feet. Feet. So really, this is like a 50 foot by 33.3 feet. Yep. Yep. Yes. And that should make sense because if this is 50 foot, so really what we have going on here is this is 50 foot and this is 33.3. This is shorter because there's 3 of them, right? And I want to use the least amount. Like if this was 50 by 50, then this would be taking up another 50 feet, right? Instead of just whatever. So that's why he is smaller, because there has to be like 3 of them, right?
We didn't have to do all that.
Why? What do you mean?
There's 3 of them going that way. 2 of them going that way. So we 2.
Well, we could have, this could have been like 40 and then this would have been something else. I don't know. Maybe so. Okay. All right. Yeah, I get what you're saying. Like these two added together would need to be the same as these 3 added together, right? So it'd be 100 each, right? So like those 3 and plus those 2 would have to be 100.
So perfect square.
Yeah, because that would be a perfect square, right? Yeah. Yeah, a perfect square would be 50 by 50 by 50. Yeah, okay, all right. Okay, that's it. All done. Monday we will start chapter review, or not chapter review, semester review. Woo! And, yeah.
No, thank you.
No, thank you. Okay, sorry, you have to do it anyway. Okay, bye, Carter.